In this lesson, we're going to add one more integration technique to our toolbox. It's called partial fractions. So our learning target is to simply find antiderivatives using partial fractions. You may remember that in our last lesson, by parts was our first BC only topic. This is also a BC only topic, and we have one more BC only integration technique to add to our toolbox until it's completely full. So to remind you, with both substitution and by parts, we were integrating a product of two functions. With substitution, the functions were related by a derivative. With by parts, the functions were unrelated by a derivative. And so to contrast that, the idea behind when we need to use partial fractions is that it's a quotient with two factors at the denominator. So it's fairly easy to pick out because you'll see an integral with a big quotient. And as you can probably notice, we have a trinomial here, but we can spend a few seconds and factor that. So let's go ahead and start with that, and we'll work through our steps as we go through this first example. So by factoring the denominator, I now have a quotient with two factors in my denominator, and I have done the first step. Often you're given a problem and the denominator is already factored, which is nice, but it didn't take too long. So let's go ahead and look at the second step. It says to separate the fraction into a over the first factor plus b over the second factor. So these a and b are numerators that we need to figure out what they are. And if you're wondering, well, is that legal? Algebraically, yes, it is legal. It's a process called decomposition. So let's go ahead and start that process on our example. So our integral, which was 1 over this denominator of two factors, is going to become the integral of a over our first factor, x minus 3, plus b over our second factor of x minus 4 dx. And as I mentioned, this process is called decomposition. It's basically going in the reverse direction of finding the LCD. So normally you would start with something like this in algebra, and you would have to find the least common denominator to add them together. So we're basically trying to break this fraction apart so that it's easier to take the antiderivative of the parts. So the first step in finding our a and b values, because that's going to let us proceed and take the antiderivative, which is the whole idea behind this process, we're going to do something with this equation that we've set up. We started with our first given integral, and we set it equal to its partial fraction. We're going to take that equation and multiply both sides of the equation by the LCD, which is this x minus 3 times x minus 4. What that does is it's going to cancel out the x minus 3, x minus 4 in the denominator here, and then cancel one of each with the two fractions on the right side. So let me show you what that looks like. So when the denominator canceled here, I was left with just a 1 on the left side. When I multiplied a over x minus 3 by x minus 3 times x minus 4, the x minus 3's would cancel, and you're left with a times x minus 4. And the opposite thing happens when you multiply this b over x minus 4 times the LCD. The x minus 4's cancel, and you're left with b times x minus 3. So this equation is going to help us find those unknown values of a and b. As you know, it's impossible to solve an equation that has two unknowns, so we're going to use a little clever trick that's going to allow us to cancel out one of the unknowns so that we can look for the other unknown. Let me tell you what I mean. So for this first factor, if x is equal to 4, this x minus 4 is going to be 0, and it will cancel out the a. That will allow me to take this equation and solve it for b, because I'll only have 1 equals b times x minus 3 left. Knowing that x is 4, I can substitute that in, and it looks like b times 1 equals b, so b equals 1. I'll use the same idea here. If I let x equals 3, that means this factor will be 0, it will cancel my b and allow me to solve for a. So 1 equals a times x minus 4. Remember, for this idea, I have let x equals 3. So that gives me 3 minus 4, which is negative 1. So dividing by negative 1 reveals that the a value is negative 1. So that process of finding a and b that we just finished is basically side work, and it's summarized here in your 3rd through 5th steps we set our numerator of 1 equal a times our second factor plus b times our first factor, and then we picked our x values to force those unknown values to be 0 to solve for the other. So once we've gotten through that process, our next thought is to go back to our original problem where we set up the a over the first factor and b over the second factor, and go ahead and substitute those values that we just found for a and b. So I know it's kind of a hard arrow to follow there, but our a over x minus 3 becomes negative 1 over x minus 3 plus b over x minus 4. We found b to be positive 1 over x minus 4. And now these two fractions, partial fractions, are easier to take the antiderivative of than they were in this form when our denominator was not factored or just factored into two factors or product of two factors. So our next step 7 says to separate into two integrals. So just to save a little space, I squeezed an integral in between or in front of the 1 over x minus 4 and put a dx for my first integral of negative 1 over x minus 3. And since these are both fractions with x to the first in the denominator, that's our exception to the power rule, and hopefully we're recognizing those pretty well as the natural log antiderivatives. So because this negative 1 is a constant or coefficient, I can pull it out in front. So I get the negative natural log of the absolute value of x minus 3 plus another antiderivative natural log absolute value of x minus 4. Don't forget your plus c like I just did. And I want to show you one more thing that you might be required to simplify if this was a multiple choice question. We can use a property of logs that's pretty neat to use. We do need to put the negative log following the positive log. So commutative property says we can switch those around, no problem. So if we have a subtraction of natural logs, we can combine that into one natural log that becomes the quotient. So the x minus 4 is the numerator of that quotient, and the x minus 3 is the denominator. And again, on free response, you wouldn't have to make that simplification, but on multiple choice, I'm pretty sure that they would require that. I'd like to spend the remaining time showing you a shortcut because everybody loves shortcuts. And this is called the Heaviside Cover-Up Shortcut, which is kind of a funny name. Heaviside is actually the name of the mathematician that discovered this, created this, however you want to think about it. But it's literally a cover-up method in that we will use our finger to cover up one of the factors. Let me show you what I mean. So for our original problem, we recognize as partial fractions. We can look at this factor, x minus 3. We know that an x value of 3 would make that factor disappear. So we picture x equals 3 in our mind. We cover up the x minus 3, and we have 1 over x minus 4. Now, knowing in our mind that x is 3, that gives us 1 over 3 minus 4, which is negative 1. So negative 1 should be the numerator of the factor that you covered up. So if you look here, that's exactly what happened. Let's try one more time because it's a little tricky. We've got another factor of x minus 4. That factor will go away if my x value is 4, so cover that up. We have 1 over x minus 3. If x is 4, we get 1 over 4 minus 3, which is 1 over 1, positive 1. So the numerator of the factor that you cover up should be positive 1. So look down here, and that's exactly what we got, positive 1 over x minus 4. So if you like shortcuts, you can remember how that works. It's kind of tricky, but very neat. But if you're like me, I like to confirm it with the algebra. That works too. So that's just a nice option. So since we have about a minute left, I thought we'd go ahead and start the next example. There's only 2, some more time in class to do other things. So since we just talked about the shortcut method, why don't you pause the video and see if you can do that with this problem and predict what the values of a and b will be. And let's go ahead and work through it algebraically to confirm. So we separate our factors in the denominator, which was already factored. It's nice. So we have a over x plus 1 plus b over x plus 2. And we're going to write our equation, which takes the numerator, and this time it's not just 1, it's 2x, equal to a times the other denominator plus b times that denominator. So let's set that up. To make a disappear from this equation, we'd let x equals negative 2. That would leave us with 2x equals b times x plus 1. And the reverse would happen. B would disappear if we let x equals negative 1. 2x equals a times x plus 2. Go ahead and try to solve this.